Okay, here is a problem. We have a flea, right? And when jumping, they have really amazing accelerations, 1,000 meters per second square. That's the acceleration of a flea. But this acceleration happens only over a very short distance of 0.50 millimeters. So if a flea jumps straight up, and if air resistance is neglected, which is not a very good approximation, but we are going to use that for this problem, how high does it go? So we want to figure out how high does the flea go if it jumps. So again, we are going to use a recipe: prepare, solve, and assess. So let's start with prepare. So let's prepare our problem. So we need to figure out what type of motion is that. So this is the ground. So then let's draw a motion diagram. So initially the flea is accelerating, right? So accelerates. So the speed is increasing, and then after that, then let's just put one more here. After that, then it just is free fall motion, right? So the speed starts decreasing, right? And these graphs are not to scale, so let's draw. Now this is the first part of the motion, right, from here to here, and then this is the second part. And so we want to now think about this in terms of a picture. So here we have a coordinate system. We're going to call this y, and then instead of naming things initial and final, because we have a multiple times here, so we're going to name this 0. Then here we're going to name this 1, and here we're going to label this 2, right? So the times 0, so this times 0 is always going to be 0 because we can always set our stopwatch at that time. Then y0 is going to be 0, and then v0, that is the initial velocity, that is going to be 0 because it starts from 0, right? So then when we get to 1, so we have here then time 1, that we don't know with time what this time 1 is. So y1, that is the time that it takes while it is accelerating. It is 0.5 millimeters, right? 0.5 millimeters, right? And then we have v1, and v1 we don't know. We might need to find that. And then let me just erase this prepare here, and then just rewrote this here. So, and then for 2, when it gets to the top, then we have T2, which we don't know. We have V2, that is 0 because it reaches the highest point. And then we have Y2, which we don't know and we want to find. So this is so the flea is right here, so accelerates with A0, and A0 is equal to 1,000 meters per second square, and then from here to here it goes down with A1, and A1 is equal to minus 9.8 meters per second square, which is gravity. So that is our problem. So we have 3 points, 0, 1, and 2, and we have values for the 3. So now we need to start solving this problem. So the first thing we need to do is figure out this. Well, we can start backwards, right? So we want to find y2. So let's write an equation for y2 and see how we can solve that. One equation that can help is that, so remember, let's write our 3 equations here. We have v final is equal to v initial plus acceleration times t final minus t initial. That's one equation. Then we have y final equals y initial plus v initial t final minus t initial. plus 1/2 a t final minus t initial square. And finally, we have v final square is equal to v initial square plus 2 times acceleration y final minus y initial. So in this problem, this is a y here. In this problem, we need to make sure that we know with our initial and final r at each step of the problem. So we want to find y2, right? So we an equation that could help is this one here, right? This equation. So we can write that v2 square, right, which would be my final now, is equal to v1 square plus 2 times and then minus 9.8, which is my acceleration. And let me just write this as a1 for now, right? So we can keep our symbols. Then I want y2 minus y1. So let's see. I know y1. This is what I want, y2, right? That's my maximum height. I know this guy. I know a1. I know v2. This is 0, but I don't know v1. So then I'm going to need to find v1. So to find v1, then I'm going to use now. I can use the same equation again, and I can write that v1 square is equal to v0 square plus 2 times a0, which is the acceleration in this segment, times y1 minus y0. So what I've done here is I want this guy here, y2. So y2 depends on the values of 1, right? So when I use the equations from 1 to 2, 2 becomes my final, 1 becomes my initial. Now, if I want to find values at 1, then I need to use they depend on the values at 0. So then for that, then I can use my equations with 1 being final and 0 being initial. That's what I've done in these two equations here. So now I can solve. I can start with this one here. So I can solve, and then v1 square is equal to, well, this is 0, so it's 2 times a0, and then this would be 1, a0 is what? a0 is 1,000, right? 1,000 meters per second square, right? And then I have the y1 minus y0, which is the displacement, and I need to change this y1 to meters. So 1 millimeters is 10 to the minus 3 meters, so this will become 0.50 times 10 to the minus 3 meters. And then, so then I can go ahead and solve for this here. And so I get that v1 is equal to, v1 squared is equal to 1 meters per second. If I solve for this equation here, because this is 10 to the 3, this is 10 to the minus 3, and 2 times 0.5, they cancel out. So v1 then is equal to 1, this is meters squared per second squared, so this is 1.0 meters per second. So I have this first value that now I need for this equation. So then I can solve for v2, for y2, and I get that y2 minus y1 is equal to v2 minus v1 and this square divided by 2a1, that is from this equation here. And then I can write now that, well, this is 0, so I get minus v1 squared divided by 2 times minus g, which is a1. And then I can put the numbers in there, and then I get that this is minus 1.0 meters per second square divided by 2 times minus 9.8 meters per second square. And then I can solve for this, and I can get a value of V is equal to 5.1 times 10 to the minus 2 meters, which is equal to 5.1 centimeters. That's how high it jumps.